Okay, so now know-how solutions. So we're a company that is focused on helping people develop better software, more secure, more safe. And basically, we're focused on compliance and product security. We offer multiple things. Amongst them is we provide tools to help, um, as I said, comply and improve security in your systems, such as low-level debugging tools, such as Lauterbach, Sager tools, and so forth. We also have analyzers. We have compilers and so forth. And most importantly, we also offer training courses. So we train developers in applications related to embedded systems and IoT solutions. And we were founded in 1991, and we have 3 offices. We have one in Finland, one in Sweden, which is the headquarters, and in Denmark. So now that we're done talking about what we do here at Know-How Solutions, let's dive into the outline of the webinar today. So this webinar, I split it into 3 parts. The first part, I'm going to give you a general introduction of what ARM Keil is and what CodeSonar is. So remember, this webinar is particularly focused on the integration on SAST, or simply helping you streamline your static analysis using microvision. However, it goes beyond that, and I will make some key remarks here and there just to let you know that it's beyond what I'm showing here. And in the second part, I'm going to have a demo. And the demo is split into 2 sections. Section number 1, which I'm going to use microvision, which is part of Keil, and it's the IDE. And then the second part will be through command line. So you know that you're not really stuck with the IDE. If you don't want to work with it, you can actually also use command line. And this expands to other build systems, if you will. And then the last part, I'm going to have a summary of what we covered and then a Q&A. So let's start with the part number 1, which is the general introduction. The first part that I'm going to introduce is Keil MDK. So the first question is, what is Keil MDK? So it is a set of tools to create embedded applications for more than 10,000 ARM Cortex-M processor-based devices. And MDK consists of MDK core, that is basically the IDE, the microvision IDE, which is, by the way, only for Windows. However, as I said, this is just so you know how to use Keil and CodeSonar together. However, you can expand this to other things. And this IDE supports all Cortex-M devices. Now you have ARM compiler for embedded, including assembler, linker, and highly optimized runtime libraries that are tailored to ARM Cortex-M based devices for optimum code size and performance. And there's also a functional safety qualified version of it. Now, the second part of Keil is the software packs. And software packs can be added at any time, which makes new device support and middleware updates independent from the tool chain. So device support is added via device family packs listed on the CMSIS pack index. CMSIS offers software packs that contain components for core support, for DSP, for neural network libraries, and a free-to-use real-time operating system. And MDK provides royalty-free software components for communication peripherals in microcontrollers such as TCP over IP, USB, file system, and graphics. And the ARM FUSA runtime system is a set of embedded software components qualified for use in the most safety-critical applications in automotive, railway, medical, and industrial systems. And lastly, the probes. So MDK supports many different debugs and trace adapters. So they have ULink Pro, you have ULink Plus, ULink Plus, ULink 2. And ULink Pro is for instruction trace-based code coverage and performance analysis. And that's the one that we're going to be using during the demo. Now, how does it work? As I said, we're going to be focused mainly on how to use it with microvision. However, so I'm just going to show you what you need to know so the demo doesn't get all confusing. So here we have the general IDE, and this button over here is the target options. So if you click on it, it will allow you to set up your project. So from the device, the target, the output listing, the compiler settings, and so forth. And the only change I'm going to make here, even though there's so many changes that you can make, is in the tab debug, because we're going to be using the Ulink Pro Cortex debugger, which I mentioned earlier. Now, the other thing you need to know about this is how to build your project. So this button over here, the one to the left, is to build, or to rebuild, the one to the right. And to flash to a target, you can use this button to download it to flash memory. Now, let's continue to introduction to CodeSonar. Here, I'm going to take a little more time because the focus of this webinar is mostly on how to use static analysis. So I want you to understand how CodeSonar works and what it is. So first, just like before, what is CodeSonar? So CodeSonar is a robust and flexible tool for locating bugs in a software project. Employs unified data flow and symbolic execution analysis. Doesn't rely on pattern matching or similar approximations, and finds 3 to 5 times more defects on average than other static analysis tools. So how does CodeSonar accomplish this? And most importantly, also, it's important to note that CodeSonar focuses not only on compliance, but also in memory corruption, memory leaks, and other type of problems that are very, very important when you're working in safety and security critical projects. So how does it work? It uses the built environment, which means that every compiler call will be tracked by CodeSonar. From there, it knows how it's built, and it builds an abstract model of the entire program. Then from this model, it uses the symbolic execution engine to see how many paths are possible. Then it prunes the ones that are unfeasible, creating a control flow graph, and then it traverses the whole tree looking for defects. So in a more graphical way, let's look at this graph. And of course, here I'm just showing how does it work from the point of view of using CodeSonar with source code. However, you can also use it with binaries, which I will not get into, but it's important to know that if you're really diving into security, you should definitely take into account binaries before deployment. But anyway, going back to the slide. So we have the source code. You extract your model and you create an intermediate representation. So the first thing is that you have your database with all the symbols from all your project. Then you take those and create an abstract syntax tree, which is just the tree of all the potential options that you have of how the program should run. Remember, static analysis, you don't run your application. So it's just looking at the paths that it should go through. Then it prunes the ones that are infeasible, and then creates your call graph. The call graph is sent back to the analysis stage, and then it's outputted in a results user interface. So CodeSonar can analyze source, and the languages that it supports are C, C++, Java, and C#. You can also do CodeSonar for binaries, as I said. And you can also analyze additional languages through third-party integration. So what are a CodeSonar strengths? Well, first, let's call them the hub, the web GUI, and the visualization. All that means is the hub is simply the database where all the information is stored, and then the web GUI and visualization is just simply how you can access and post-process this information. Now, it's straightforward to analyze, very simple, and you're going to see it throughout the demo. The warnings are very comprehensive. There's a lot of information, so there's no doubt about what's going on in the program. Metrics, by default, there are some basic metrics that are calculated, but you can also use like standard metrics like HIS and CWE integration, of course, for security. And then if you're not comfortable using CodeSonar as is, there's multiple ways that you can interact with other third-party pieces of software because you can export in different formats, and you can filter all your results. So it's very simple, and we're going to look at the interface in a second. But before we dive into it, the most important thing is that there's a ton of applications where this is mandatory, and the things we need to know is what CodeSonar covers. So if you're working with IEC 61508, meaning in electrical applications, or functional safety in automotive software, such as ISO 26262, airborne system, industrial systems, medical devices, or railway systems, these are all areas that CodeSonar covers. Now, most importantly, is that a lot of times you're going to work in a project where you need to comply with certain standards. And so central to each of these functional safety standards are safe and secure coding. So here are the list of standards that you can use, that you can comply with using CodeSonar, using AUTOSAR, this is SIG, ISO, IEC, TS 17961, JPL, MISRA, if you're working in automotive, MITRE CWE, OWASP, SEI CERT, you're working mainly in security, and JSF. So evidently, depending on what you're working on, some of these may apply or not, and you can actually analyze focusing on each of these standards separately, or you can bundle them together depending on what you're working on. So I'll show you that throughout the demo, where we're going to focus mainly on automotive applications, and we're going to focus on the MISRA standard. And last but not least, there's a functional safety kit. So this safety documentation kit is particularly useful for teams developing software that has to adhere to IEC 61508, ISO 26262, and Senelec EN 501, and they're all certified by Exida. Okay, so let's now talk about what CodeSonar looks like, or at least the graphical interface. So the graphical interface is just like any other graphical interface. It provides a great deal of flexibility. You can view, you can search, you can sort, you can directly interact with a database. You can make annotations and use annotations from other places. And you can create queries, HTTP queries. Remember, well, we didn't really talk much about the hub, but basically the hub is where all the information is stored. It's a web server. It's with a database, and that's the way you can access it. You can access it directly via the user interface, or you can create HTTP queries using Bash or maybe Python. So now that we're looking at the interface, this is the general idea. At the very top, here you have something called the hub. This is just an address with a port. Here you have the project you analyzed and the status. If you click on the project, it will take you here where you see all the warnings that are being produced by the analysis and all the files that were included here to the left. Here, the CodeSonar color codes this red, yellow, or green, depending on the severity of the warning and how critical it is to take care of. Then an ID, which is unique, so you can work with different people, and it will recognize for each analysis increment that it's the same error unless it's being taken care of. You have a class, if it's leak, use after free, tag mismatch, which will all depend on the significance. So it's divided into 4. So it's reliability, security, style, and so forth. Where was located, the line number, the procedure, and so forth. If you click on any of these, so you can go from warning to files to procedure. Let's go to files. You will see all the files that were included in the analysis and the lines that had code in each individual one of these. And then if you go into procedure, you also see which is the procedure that are within the files, and by default, cyclomatic complexity is calculated. Furthermore, if you click on the actual warning, let's say we pick a null pointer of dereference, it's going to be split into three areas. You have the report heading, you have the annotated code, and the change warning section. And here simply is the general information about the warning. The annotated code is just in-depth information about what happened. Why is this or might be a vulnerability in your code? And then, of course, what to do with it. So you assign a person, you say the priority, and you deal with the issue. Now, here you can get even more information. So if you click on warning details, it gives you a list of categories, and here are all the standards that it complies or it violates rather. So you can just do it out of the box, and of course select each individual one you want, or you can actually use presets, which we'll be using in our demo, to create a focus analysis in one of these categories. And of course, you can show more details, know which analysis it is, when it started, when it finished, and so forth. Furthermore, you can click on this link over here, which is like the particulars of this C code. So if you have a large project, you might have different ones, and it tells you the general metrics, such as how many blank lines, code lines, comments, so forth, which is the compilation unit, the analysis, and once again, when it started, when it finished. Now, the most important part is really seeing how powerful knowing or getting enough information about the warning has on how you can fix your code or ensure security. So for instance, here, if we go back to the original snippet of code, you see that there's something here that I didn't mention before. There's this arrow that goes two ways. Because if you think about this code, let's just go through it real quick. Switch, it has as an argument a random number. So now the vulnerability pops up, or at least this warning, null point dereference, if you try to dereference this variable, Q, because Q was set to null. And it says it right here, event 2, Q is set to null. And because you try to dereference, then warning pops up in CodeSonar. However, this could be a particular case that never happens, and that's why it's important always to have a person looking over the code, because this could be something that will never happen in your code, or maybe it's something that you didn't think it could happen at all. Because as you see here, this control flow notation tells you that this will only happen if this is case 1. If it never goes to case 1, you would never see that this would have happened. Now, if you don't know what null pointer dereference is, you can always click on any of these question marks that you see all over CodeSonar, and it will take you to the manual, to the place where it gives you all the information and what it has to do with security or the particular significance in the code, in the analysis. So, okay, so this is just repetition of what I mentioned before. So the hub data and the CodeSonar GUI can be exported in a variety of formats. So even if you're not working directly with the GUI, you can always use, say, CSV, JSON files, or serif, which are standard formats that you can use in other user interfaces. Now that we covered this, I'm gonna go ahead, and the demo is gonna be it's gonna be a video, because the analysis takes a little longer than I would like it to take. But first and foremost, I will explain which tools we're using. So these are the tools I'm using during the demo. I'm using MDK, particularly the IDE, so Microvision, Startup, and whole hardware abstraction layer code, TMC's codes, and the graphics library, and Ulink Pro on the Keil side. And on the CodeSonar side, I'm using CodeSonar for sources. Remember, you can also do CodeSonar for binaries. And this is what I'll be using. I'm using version 5.38 of Microvision, which includes ARM Clang version 6.19. And here I actually have I updated the version of CodeSonar. I actually used version 8. And the board and the Ulink Pro that I'm using. So I'm using the evaluation board MCB-STM32F400, which is a Cortex-M. Okay, so now I'll go ahead and show you the demo. The first thing we're going to do is open an empty project on Microvision. I will go ahead and hover over the Pack Installer button and click on it. This window will pop up. So to the left side, you have the tabs Devices and Boards that are supported by Microvision, and to the right, the downloadable packs and examples that depend on the hardware you have selected. So I'm going to go ahead and select my MCB STM32F400 board and select the example EMWin GUI demo. Click on copy and copy on my C drive, and it will launch a new Microvision instance. While this opens, I just want to make sure to explain why I picked this particular project. And I picked it because I want to pick the project you will actually see it working on a board, so you know it's an actual embedded piece of code and not just some hello world type of code. And even though it's a relatively simple code, it makes the point across. So as you see, now the new instance of Microvision has popped up, and the abstract is up. So this is an EMWin graphic library demo for the Keil MCB-STM32F400 evaluation board. Now, to the left side, you see the project window, and it's just the source tree, or the project tree rather. And it's just composed by common things such as the source code, all the board support, the interfaces for the particular device we're using, graphical libraries, and so forth. So the next thing we're going to do is build our project. If you want to build your project, there's multiple ways of doing so. You can just click on this button, build, or press F7. So I'm going to go ahead and build a project. As you see here in the build output, the C code is being compiled into object files. And once it's done, it starts linking and producing an executable, which in this case it's the GUI demo.axf. Okay, fantastic. So now the next thing I want to do is, just as I said earlier, is show that it's actually meant to be used in an actual hardware, in an actual target, in a board. So first, I'm going to show you that I'm using this MCB board I was talking about earlier, and I'm showing it on the top right corner of the screen. And I'm connected to this Ulink Pro from Keil. Now, this can be used for low-level debugging and for flashing, and this is not the purpose of this particular demo, but it's just to show that it works on hardware. So before I flash it into the board, I'm going to click on this button called Options for Target. And here I'm going to go to the tab called Debug and select the debugger that I'm interested in. So in this particular case, it would be the Ulink Pro Cortex debugger. Okay, I'm going to click OK. So now we're all set up for flashing. I will click on this button called Download to download the code to flash memory. Okay, so as you saw, this was done in multiple steps. First, we erased the flash memory, we programmed it into the board, verified that it was okay, and the application started running. And actually, you should have seen this happening also live on the board right here. Okay, now that we know this is actually real code for a real target, let's just remove the camera of the target and let's focus on our actual code base. So this is what we're working with, and we want to analyze. We want to see if there are any vulnerabilities in our code. Okay, fantastic. So the next thing we're going to do is hop onto the CodeSonar configuration tool. So as you see, this configuration tool will help us listen to the compiler calls for this particular project. Okay, so now I'm here. This is my hub, and these are all the options and configurations that I can apply. The only thing that I'm interested for this demo is this option called Start Build Analysis. So I'm going to type in 14, and then it will ask, would you like to start the CodeSonar Windows Build Wizard? And the answer is yes. Okay, so now this window you see here is the Build Wizard. Because I don't need the configuration tool anymore, I'm just going to minimize it and put it in the background. I'm going to reorganize the screens now so you don't get confused. So the first thing I'm going to do is I'm going to open the web browser where I can see all the information from CodeSonar, and I'm going to move this information, our piece of code, or our project rather, to the left. So now on the left side, we have our Keil project, and to the right side, we have CodeSonar. Okay, let me bring back up the build wizard. So I'm going to use this to set up a project that can be analyzed. The project is already set up, actually. All we need to do is point the wizard in the direction, or the directory rather, where this is located. So I prepared a configuration for it. So all I'm doing is saving this project, giving it a name, matching the hub address, which is this address that you see up here, and creating a local analysis in my local machine. And I'm not asking for authentication, although you could actually choose to ask for password or certificate. Next thing, I will click Next. Here you can customize your analysis. So what I'll do is assign a preset. So as it says here, presets are prepackaged configurations that help tune CodeSonar to your needs. And sometimes you're going to be working on projects that require certain standards to be met. You have some requirements. So here you have multiple options, and you can bundle them together and actually create customized ones. But let's just focus on the ones we have available out of the box. I'm just going to go ahead and look for maybe Mesra 2012. Let's jump to the next configuration parameter, and it's configuration file. So you can actually customize the way CodeSonar behaves by editing the configuration file. In this particular case, we're not going to do anything, so we're going to leave it as is. Then we jump to the next option, which is what should we be looking for? And as I mentioned before, CodeSonar listens or records the compiler calls in the background. So if we actually read this, it says these are the programs that might invoke a compiler. If a program not listed here invokes a compiler, then it will go unnoticed. But in this particular case, we're listening to everything. Everything what? Everything that's pointing to this project. Okay, fantastic. And then last but not least, if you're using CodeWarrior IDE, then you can set this up. And that's all you need to do. You can click record, and it will start recording. Now, once you click recording, this is just in idle. This is just waiting to see when the analysis will start, which is when the compiler calls are present. I'm going to reload our web browser so you see that a new project pops up, Microvision GUI demo. Okay, so that means that if I start Now, building my project again, I will be able to analyze this project and store the analysis in this section over here in the CodeSonar web browser. So I'm going to go ahead, I'm going to rebuild my project. And just like before, you start seeing, okay, there's something happening here because it's starting to record. And on the left side, on the build output, you start seeing that there's also output for the compilation log. Now, on the right side, the CodeSonar version is a lot more verbose because this is actually outputting what's happening in the background, whereas this is just displaying that it's compiling a part of the code. If we added an additional compiler flag to add verbosity, they would look identical. And most importantly, here it also shows not only the flags that are being used, but it also shows which are the arguments that have been used for this particular project. Okay. Perfect. So let's just finalize this. Once you finalize, it will ask, do you want to build another project or not? We're not going to use this anymore, so I'm just going to exit. And here you see that it says build. If I refresh my browser, now it's linking. So it goes through different phases for the analysis. Evidently, if it's just building, the analysis hasn't started. And then it starts linking because it's putting all the information together from the tree that we build, the internal representation, and then building the graph that it needs to perform the analysis. Now let's just give it a second until the analysis is done. Once the analysis ends, you can click on the project itself and you will get all the warnings classified and scored. I'm going to maximize this as we're going to be looking mainly at the warnings generated. And here we see that it's red colored. So CodeSonar color codes the warnings in green, yellow, or red, depending on the severity of the warning, and it scores from 0 to 100, 100 being the worst and the most critical vulnerability. And those are the ones you should be solving first. Here, this is very straightforward. You can see the ID, which is unique to each of the warnings, what is the class, what is the significance, in which file it occurred, in which line number, and so forth. So let's just scroll down to see some of the warnings. So we see that there's a lot of inline assembly code in this code. The use of string cat, implicit function declaration, multiplication overflow of size, addition overflow of size, buffer overruns, missing final else. Okay, fantastic. So we see that we have a large variety, and some of them are regarding style, some of them are security, reliability, and so forth. Let's just look at the how the warning looks from the inside. So let's just select inline code assembly for this particular procedure. And then let's maybe open use of string cat, just to have maybe two different ones and see what is the problem and how does CodeSonar express this issue. So inline assembly code. If we scroll down, we see the piece of code, we see the full path, and we see that is this header file. And the reason is that you have declared inline assembly code without encapsulating it. So if we keep scrolling down, we end up in a large message that says assembly language may be used to implement anti-debugging or anti-VM techniques. It should be examined for potential malicious behavior. And it tells you where it is. So it's very explicit. It gives you a lot of information. It tells you in which line it occurred. Now, if you want even more information about this, let's say you don't know what this means or how to even handle it, you can always click on the question mark or any of the question marks in CodeSonar. And if I click here, it will take me to the manual and tell me what this inline assembly code is and to what standard it belongs to. Let's just reset the size. Fantastic. So here, for instance, we see that inline assembly code. A procedure contains inline assembly code. And here you can see the class, the significance, mnemonic, and categories. So even though it belongs to MISR 2012, it also applies to other standards as well. If we go ahead and click here, we see all the checks. And we see that it's for all versions, it is required, it's undecidable, and it's a directive, which it's not a rule, but it's a directive, and it's displayed by this D over here in the rule. So assembly language shall be encapsulated and isolated. If it's not, then a warning will be triggered. And of course, as I said, it's a high-level vulnerability in this particular piece of code, as we saw that it was color-coded red and scored 71. So you got a lot of information. So now let's see our other example. We have, for instance, the use of string cat, which is a common function to use. And if we scroll down, we see that here we have like 2 examples of string cat that have been used. And here it says that this use is not recommended. It is correlated with security or safety problems. So let's do the same thing. Let's click on the question mark and see if there's any explanation. Once again, it not only belongs to the MISRA standards, but it also applies to other sets of standards, including security ones. And these are all the functions that are triggering this function. Now, there is a solution for it. You can use a function that does bounds checking, such as string with n cat, strcbcat, or strch cat. So these are options that would remove that particular vulnerability, and then you would comply with MISRA for that particular rule. Now, you can also do multiple things since we're here. You can check your metrics. So let's click on metrics. You can export a metrics report. You can create a new report. And if you create a new report, then it will show the options of the things you can include in your metrics report. By default, blank lines, code lines, comment lines, lines of code, lines with comments, mixed lines, total lines, include file instances, top-level file instances, and user-defined functions are calculated by default. But for instance, if you want to include modified cyclomatic complexity or cyclomatic complexity, you can also add those to your reports, and you will see the numbers and the granularity for them. But even more in depth, you can go back to your analysis, and maybe you want to show someone in a more graphical way. In other ways, maybe post-process, adapt the data a little more, a little nicer, so you can show it to people that maybe are not that interested in the in-depth issue with the warning, so we can actually create charts. So for instance, let's say you are interested in looking at the significance and just a chart that shows how many of each of them you have. And as you see, most of these issues are style issues. And you see the quantity of them, of course. But some of them, a good quantity, 229, are actually security vulnerabilities. And this will allow you not only to see this, but you can actually group them together, either using this or the search bar. But if I click on it, this will just isolate only the security vulnerabilities, and maybe you want to just focus on them first. Let's say you have a developer that's just focused on security, you can click on it and assign him by assigning the owner. So anybody who has access to this, either myself or Heidi or anybody else, they can handle this particular ticket. So as for this demo, we have covered how to build a project in Microvision and without doing much, analyze it right away using CodeSonar's build wizard. So let's move on to the next demo. The second part of this demo is simply how to show you how to use CodeSonar in the background, analyzing a Keil project that is also built in the background. And the reason is most of the time when you want to do some tests, maybe you don't want to do it manually and you don't want to have a user interface. You want to have everything in the background. So how would you do this with Keil, and how would you streamline the use of CodeSonar into your project? So that's very simple. So what we're going to do is just, I'm using a PowerShell to the left, and we're just going to use this command. So CodeSonar is simply CodeSonar, analyze the name of the project, which I will give it the same name, then the address of the hub and the port, which is this number that you see here, then the build system that is being used by Microvision, UV4, minus B is build, minus J0 is do not use the user interface, and then the name of the project, the Microvision project. Okay, so if everything is fine, this is the most minimalistic way of setting up an analysis for a Keil project. Evidently, this is not going to do exactly the same that we did with the wizard, because we would need an extra flag, an extra switch to assign the preset for the MISRA 2012 like we did before. Now, this is running in the background, and here you don't see anything. So let's just refresh the screen. As you see, this is in the building stage. So let's just give it a second until the analysis is done. So once the code has been analyzed, you can do the same thing we did before. So I'll go ahead and click on Microvision GUI demo, and it will bring up the warnings that have been generated for this particular analysis. And as you see, these are slightly different than the other ones, because what we did here, if we recall, we did just generic analysis, which is just the one that comes out of the box with generic warnings for this code. However, before we actually did a MISRA analysis targeting, standard compliance. So if this is true, and as you see, this is another analysis. When you're in the home page and you click on the project, like I did, it will by default take you to the last analysis that we did. But actually, you see, this is not the first analysis that we've done. You can actually compare to other analyses. So if we compare, let's say, to analysis 1, so we're going to compare 1 and 4, it will show all the differences between the analysis 1 and the analysis 4. And as you see, these are the ones that have been gained or lost, and most of them have been gained. But as you see, these are all the ones that I was focusing on before, like the inline assembly code and the string cat and so forth, plus other ones. But these are the ones that were done in analysis 1, and the reason why they pop up here is because they belong to the MISRA analysis, but not to the general analysis. So you can tailor your analysis depending on the focus of your project, and make sure that your code is as secure as possible. With this is the end of the demo, and thank you so much. Okay, so we're back on the slides. I hope you enjoyed the demo. So the part 3 is a summary. And the first thing I want to make sure is that you actually understand how this extends to other things. So in the demo that I showed, we were focusing mainly on microvision, but evidently if you have an ARM compiler, let's say, and you're using any other IDE, or you're working with other code management tools, or CI/CD using GitHub GitLab, then you are you can also use CodeSonar with these. And this is very important to understand, because if you're working with other people, if you are actually focusing on DevSecOps, which basically if we focus on the image to the bottom left, you're going to see the standard image that people use for CI/CD, for DevOps, and that focuses mainly on quality assurance. But if you actually want to dive into DevSecOps, each one of the stages, from planning, coding, building, testing, release, deploy, and so on, every single stage needs to ensure security. So for instance, if you're working on with other people, like you see here, what you really want is not for everyone to be able to work together. So if someone is creating a feature 1 and someone is creating a feature 2, maybe they have an IDE that's compatible with CodeSonar, and they can do their analysis locally, when it's like when you don't need really thorough test, and then you do integration test once you merge it to the main, and maybe you have something more thorough, like let's say in embedded systems, maybe you're more interested in concurrency issues, or some particular issues that are of very interest, that are very time consuming. The analysis are very long. So maybe you don't want to do that every single time you do it locally, but so you allow to treat the code, not only analyze the code for security in code, but as code, like by the developers, and also by the main branch once you are merging it into main. So what did we cover? I gave a introduction to ARM Keil MDK. I talked about what it was, how it works, and what we used for the demo. Same thing with CodeSonar. I did a general introduction. I showed you more or less how it works, and most importantly, I mentioned, and I tried to be as comprehensive as possible to include SAST and standard compliance into your ARM Keil projects. 2 ways: using microvision, which is the IDE, and UV4, which is command line. But as I said, this is not only linked to this. If you have an ARM compiler, and let's say you have a make project or a CMake project, it works very similarly. The Windows wizard, it's only enabled in Windows. However, there's the way it works in command line is the same thing as if you would use it in, say, Linux and so forth. So if you have any sales questions, you can always contact my colleague Joachim Nilsson in Sweden. Or if you have more questions that maybe you didn't have now, but they pop up later, you can always send an email to support@knowhow.se, and I will take a look at them. Just make sure that in the title you put the name of the webinar, so I know it's webinar related. And I really hope you enjoyed the webinar, and I hope to see you in the future. Thank you very much. Bye.